Good morning. Let's start today's session. So we have studied all combinations of R, L, C, RL, RLC and RC circuits. Next we see three types of powers. First one is apparent power, active power as well as reactive power. Right? So this is a triangle of power, right? So we have first one. This is our real power. The unit is in kW, which is also known as active power. And this is along the x-axis, let be the reference axis. Then at a 90-degree angle respective, we have the reactive power, or its unit is kVAR. Then the resultant of active power and reactive power will be the apparent power, and unit is kVA. Then this is phi. This is the power factor angle. Cos of phi is also known as power factor. So let's see deep into what is the concept of active power, reactive power and apparent power. Okay, so the power which is given to a circuit is known as apparent power. The power which is given to a circuit is known as apparent power. Then, if the circuit, right, this is circuit I'm dealing with, right? So, if the circuit consists only of resistive elements, the entire apparent power is being utilized by the resistance and the whole power will be positive, right? So this is, in this case, the reactive component will be equal to 0. So only active component exists. So only active power component exists in a resistive circuit, purely resistive only circuit. Suppose I am inserting an inductor into a circuit. Here comes our reactive power. Here comes our reactive power. And again, if I am adding a capacitor onto it, then also the reactive power exists, right? So the reactive power is not being utilized by the circuit, but for the functioning of the circuit, we need that reactive power. It's essential, right? But the output is only depending upon the active power. We'll see more onto it. This is the analogy which is usually used. So this is a coffee cup, right? So you know about cappuccino, Dolgan or Reason coffee and all. So what is the speciality? We are actually drinking only from this point to this point. That is our actual liquid content, coffee. The above portion, this is say the froth, the frothy portion, right? So the frothy portion is essential, which improve the taste of the coffee, or it improves the efficiency of the coffee, or say I would say it brings about the taste, right? So which accounts for the reactive power. So if I'm just mixing water and milk, right, and putting some coffee powder also, I'll get some kind of coffee, right? But we will drink it just like a simple coffee. But if I make a Dolgano or a cappuccino coffee with more froth onto it, it's really more tasty and more good. I'm just making an analogy. So, what is the total coffee? I would say this is apparent power. This is the total coffee. From this height to this height will be the total coffee height, but till the froth only the actual coffee exists. And from the from onwards, there will be a fake appearance of coffee is there. Coffee is there, but not actually there. That is a condition. So we can make analogy to the power. This whole height is the apparent power, till this water level is the real power, and the rest of the froth is reactive power. So that's how I can make. So this is our resistive element, this water element. This is our inductive or capacitive element. So in inductive and capacitive element, we'll see how it works. So I'll explain it with an example. So more technical we are moving on to. I'll define active power. So active power is the real or electrical resistance power consumption. So electrical resistance consumed the power and active power. It's a real power which is dissipated in the circuit, right? So that is active power. Then reactive power. It is an imaginary, inductive or capacitive or a combination power consumption. So it actually moves back and forth in this load into the load as well as source. We if assume that we're having a source and also a load, and if it is connected, the inductive power will move back and forth between the source and the load, and that's why it's known as reactive power. The apparent power is the summation of this active power and reactive power. I'll explain it with a simple example. This is a fan load I'm talking about. So fan, how do we make a fan? It based on the principle of induction. It works on the principle of induction, right? So a motor will talk about that later. I'm just telling you the crisp of the requirement of active reactive power explanation. So the fan is made up of actually this windings, this kind of windings. So starting winding and main winding are there, and that winding will consist of that inductive part and what resistive part. So this is actually a single phase induction motor. In fan we are using a single phase induction motor. So the fan to keep running, we have to give power. So what is an induction? I have explained already. If you change the flux in a coil, we'll be able to get an EMF induced in the second coil, right? So Faraday's law states like that. So here also the induction process is going on. So an inductor should be there, because then only the induction action will occur, and then only the electrical power will get converted into the mechanical rotating power. So for that induction to happen, that inductor coil is very very much essential, right? And as we can't make a pure inductor, there will be a combination of resistance also. The resistance amount will be there. So to get a good working condition, your main winding has got more resistance and less inductance, and the starting winding will have more inductance and less resistance, like that. We'll go into details later. Just understand that there is inductance and resistance in the fan for the fan to work properly. So for the induction to occur, this L should be there. Then we can classify the power which is delivered to this resistance and the power which is delivered to this inductor. This power is known as active power, and this power is known as reactive power. That's it. So in an inductor, if you draw the power characteristics, you will get a positive and a negative portion. So it's going to and fro. But if you take the resistance, when you draw the power characteristic, you can see that it will be having only positive elements. So it will be having an average power. We have studied in pure R circuit that the resistance have only pure resistance, pure power content or positive power content. That concept you will have to understand here also. Again, for the starting of the fan, we are use capacitance. So something like this. So starting purpose, we require capacitance. So this is again an RLC combination circuit. So the whatever power which is consumed by this L and C is known as reactive power, and whatever power which is consumed by the resistance, which is used to convert electrical power into corresponding mechanical power, is known as reactive power, resistance or active power. So the power which is consumed by the inductance is stored in the form of what? Magnetic energy. And the power which is used for the capacitor is storing the energy in the form of charges. No? So those powers are not being obtained as the output, but still there, which is essential for the working of the machine, right? So the power dissipated resistance is known as watt full power, and this is known as watt less power, right? We'll talk about that later. So you understood, I hope you understood that what is active power and what is reactive power. See certain equations related to it. So this is the apparent power, S is the apparent power, P is the active power, and Q is the reactive power. So P equal to S equal to P plus J into Q. So again, according to the RMS value and average RMS value of voltage and current, we can write it like this is our power triangle we have. See, this was the real one or active power. I would say this is P. This is the Q part, right? This is the S part. As we have studied the J, what will the J operator do? If Q is like over here, if you rotate in this way, you'll get a J rotation. So it's actually JQ, right? So P plus JQ will give you S. This is phi, right? So VRMS into IRMS is equal to S. And if you multiply VRMS and IRMS into cos phi, I'll get P. If I multiply VRMS and IRMS by sin phi, I'll get Q. This is nothing but active power. This is nothing but reactive power. Very important. So this is one relation. Again, what is the unit of voltage? And volt, right? VRMS is voltage. The unit of IRMS is ampere. So what will be unit of S? I can write it as VA, no? Then we are talking about higher kilo range. Kilo stands for K stands for 10 raised to 3, no? So S can be written as kVA. The unit is kVA. Again, we can write this as kVA into cos phi. This is kVA into sin phi. Again, the unit is this unit of active power is kW, kilowatts. It's also known as wattful power. This is the unit is kVAR, reactive. kVA reactive. That is wattless power, right? One more relation for mathematical purpose. As we've already known, these are the equations. These are the equations we know, right? So VRMS into IRMS is equal to S. Also, I can write what V equal to I into Z. No, so VRMS can be written as IRMS into Z impedance. So IRMS into Z into IRMS. So IRMS square into Z is one relation. Then P, you have the equation that is VI cos phi. Earlier we have written that equation, whereas we can write V to be equal to IRMS into Z. I is again IRMS. Then we know one triangle. This is our triangle. It is known as impedance triangle. So this is Z. This axis is R. This axis is X. This is phi. So I have to find out what cos phi is. So what is cos phi? Cos phi will be is equal to adjacent side, that is R divided by hypotenuse Z. Again, we can write what is sin phi, which will be useful later. Sin phi equal to opposite side, that is X by Z. Cos phi is adjacent side by Z. So R by Z and X by Z. So we can replace this cos phi by R by Z. So I'll get I square RMS. 2I RMS are there. Z cancels. These two terms will get cancelled. So I square RMS into R I will get. See, there is only resistive component. So again it is active power or the power and resistance. Q is equal to VRMS into IRMS into sin phi, where sin phi is we have got it to be X by Z. So I square RMS by into X. So this is reactive in nature. So that's all about the equations, which is very useful for further analysis study.